For this lesson, we're going to be using transformations to sketch our sinusoidal functions. So we can graph our sinusoidal functions using transformations, but we can also graph them if we're given the key properties. And by that I mean if we're given the period, amplitude, axis of the curve, phase shift, and reflections. If we can also identify these key properties from equation, then we can use those to graph our curve as well. So to graph from our properties, the first thing we need to do is to identify our parent function. Then we'll draw our axis of the curve. We'll indicate our amplitude, our starting point, indicate our ending point based off our value of k, and then indicate any reflections. So let's look at our first example here. We have y equals -2 sine 2x minus 90 degrees plus 1. So remember, to see our k value, we need to factor out that 2. So we're going to factor out this 2, and then we're left with our actual d value, which is 45 degrees. Now, let's identify some of our key, our key features here. So first is the period. So the period can always be found by taking 360 and multiplying it by 1 over k. In this case, our k value is 2, so we'll have 360 times 1/2, which equals 180 degrees. Next is our amplitude, and our amplitude is our A value. So our A value always tells us what our amplitude is. So in this case, our amplitude will be 2. Next is the axis of the curve. So our axis of the parent function is at 0, and then our C value brings our axis up or down. So our axis of the curve is always y equals c, and in this case, our c value is 1. Next is our phase shift. So in this case, we look at our d value, and we've moved 45 degrees to the right. And how I know it's to the right is because d appears negative in the equation. And finally, we want to see if we have a reflection, and because of that negative in front of the 2, we have a reflection in the x-axis. Now, let's graph 2 cycles of the function. The first thing we want to do is identify our parent function. So because of the sine value here, our parent function is our sine function. Next, we want to identify the axis of the curve, which again is given to us by our little c value at the end here. So what I'm going to do is, on my graph, I'm going to label our axis at 1. So I'm going to just quickly add in our scale. And now let's put our axis on the graph. So our axis is at y equals 1. There we go. Next, we want to look at our amplitude. So again, our amplitude is always denoted by our A value, which in this case is 2. And this tells us how far above or below the axis our graph goes. So in this case, we're going to go 2 above and 2 below. Next, we're going to find our starting point from our phase shift. So our phase shift was given to us by the d value. So we know that our sine curve usually starts at 0, but now we're going to move 45 degrees to the right, so our new starting point will be here. Next, we're going to look at the k value, which gives us the period, so how long each cycle lasts. In this case, it's 180 degrees, so it will go from 45 to 225, and then another 180 degrees, so from 225 to 405. There we go. Now, the other thing that we need to note is that we do have a reflection in the x-axis. So our graph is going to be upside down. So now let's get to graphing. We're graphing a sine curve, so we know that it starts on the axis. Because we have a reflection in the x-axis, we're going to go down first and then up. So we go down first to the bottom of our amplitude, back to the middle, to the top of our amplitude, and back down. Now we also need to graph a second cycle, so we're just going to do the same thing all over again. Down to the bottom of our amplitude, back in the middle, up to the top, down to the bottom. And all of these dots here are evenly spaced out, which makes this very easy to graph. So that would be our final curve. Let's try another example. So for our next example, we're given the function y equals 1/2 cosine of x plus 90 degrees minus 1. So first thing we're going to do is we're going to state our key properties. So first is the period. Because we don't have a k value, the period is not affected, so we just write 360 degrees. Next is our amplitude, and our amplitude is given by our a value, so that would be 1/2. Next is our axis of the curve, which is given to us by our c value. So in this case, we have y equals -1. Next is our phase shift, which is given by the d value, which in this case appears as positive 90 in the equation. So we're going 90 degrees to the left. And any reflections, in this case, we have no reflection. So now let's graph this thing. First thing I'm going to do is I'm just going to put my scale on my graph. So we'll have 1, 2, 1. I'm just going to go up by 0.5s. Now, the first thing I need to do is I plot my axis of my curve, which is at -1 here. Next, I plot my maximum and minimum. So I have an amplitude of 1/2. So I'm going to be going up by 1/2 and below by 1/2. Next is my phase shift to find my starting point. So I'm going to move 90 degrees to the left. So my starting point will be right here. Sorry, it got a little cut off, but that's where my starting point is. Next is going to be my period. So I know that the period is 360 degrees. So that will bring me to 270. There we go. And we're just going to graph from 0 to 360. So we're going to plot all of this here, but the only part we care about is from 0 to 360. Okay, so now the next thing is we look to see if there's a reflection. There's no reflection, so we don't need to worry about that. So now let's get to graphing. We're graphing a cosine curve right now. So when we have a cosine curve, we start at our maximum. So we'll start up here. Then we go through the middle. To our minimum. And back up. There we go. So our curve is going, oops, I did the last point too high. It's going to look like this. Now we can continue this because we need to graph between 0 and 360. So now we're just going to continue our graph like this. Now, because we are graphing between 0 and 360, we didn't need this whole graph. So I'm going to erase the part that we didn't need. So, what do you notice about this graph? What does it look like? So, this graph here looks like a sine curve. So, what we know is that if I take a cosine curve, move it over 90 degrees, I get a sine curve. So that means that using phase shifts and translations, we can write equations for these curves as sine or as cosine. Let's try another example. This time we're given the following properties. So what we're going to do is we're going to use these properties in order to write an equation of the transformed equation. So again, I'm sorry that we keep having these extra signs there. I don't know how that keeps happening, but that's okay. So the first thing that we're going to do is we're going to look for our A value. So remember that our amplitude gives us our A value. So that tells us that our A value is 3, so we can start there. Next is the period. So remember that the period is equal to 360 times 1 over k. So we can use that to find our k value when we're given the period. So 720 equals 360 times 1 over k. So 720 divided by 360 gives me 2 equals 1 over k. So that gives me that k equals 1/2. So those are always going to be your steps for finding k. So that will give us our k value from the period over here, and that's how you get it. Oops, I just wrote k instead of writing 1/2. We did all that work to find it. Next, we have x, and now we figure out our d value. So we have a phase shift 60 degrees to the right. That means in the equation it's going to appear negative, like this. So how we got that. And now we have our axis of the curve, which is always our little blue c value tacked on to the end. So we'll have a -1. And the last thing is that we do have a reflection in the x-axis. So because it's in the x-axis, that will be on our a value. So now we can graph this thing. So I'm just going to start by adding my scale to the graph. There we go. Next, we plot the axis, which is at -1. And we're just graphing one cycle of this. I'm going to make sure I put out the whole thing. Next, we are going to graph our amplitude. So our amplitude is 3. So here's our maximum. And our minimum. Next is our starting point, which is from our phase shift. So because we moved 60 degrees to the right, we are going to put our curve 60 degrees to the right. There we go. And then we are going to look at the period. So because our period is 720, we know that we go from 60 and we go an additional 720. So we should end at 780. go. So it'll be right here. There we go. So now we have a sine curve. So now we have a sine curve. So we know that we start on our axis. There we go. And then right in the middle will also be at the middle again. So we'll have right at 390. And then we have another one over here. Now right in between those, we'll have our minima. So our first minimum will be at 225. Go somewhere around here. And our maximum will be right in between 390 and 780. There we go, somewhere around here. These aren't exactly accurate, but it's as close as we can get. There we go. And that is one full cycle. Okay, let's do one more example. So a sinusoidal function has a period of 180 degrees, a minimum value of 2, and its equation of the axis at y equals -1, and a reflection in the y-axis. We're going to graph two different functions that satisfy these parameters. So let's start by identifying some values here. So we have a period of 180 degrees, so equals 360 multiplied by 1 over k. So we have a period of 180 equals 360, 1 over k. We have 1/2 equals 1 over k. So we'll get that k equals 2. That's the first thing that we know. Next, we have a minimum value of -2 and the axis at -1. So let's go through and draw those. So our axis is at -1. Go. We have a minimum value of -2. So this will help us to find our amplitude. And if I have a minimum value of -2, that means my maximum value must be at 0 because they're always even around the axis like that. And we know we also have a reflection in the y-axis, so we know that they will be to the left of the y-axis. So now let's graph two different graphs that have this. So our end of the period is here. We don't have a d value, so we're going to start here. There we go. So the first one we could have is we could have a sine here. So we could start on our axis and we could go here, here, down like this. So that could be one option. And that one would have an equation of y equals our a value is 1 because we have an amplitude of 1. Then we have sine. Our k value is 2. We don't have a d value, -1. That's our first option. Oh, I forgot my negative because of our reflection in the y-axis. Or we could also have a cosine graph. So in this case, I start up at my maximum and go to my minimum right in the middle. So my other option could be Then I have y equals cosine negative 2x minus 1. And those are my two options.